Started. And I'll pull up your review. I have a big, it's not that big, but I have a Sharpie that I'll be writing with. So I'll try and get the everything right. I know that the camera's trying to adjust. So just give me a second. So before I just kind of get things started, do any of you already have any questions that we can go ahead and get started with?
Drip rate and drop factor.
Okay. I can do those. So let's look at what your review has. So that way we're on the same page.
I was thinking you could like tell us what would be on this test, like if weight-based calculations, or like she said, the drip factors, and like if it would be like the minutes or hours, or I think there was another one too, like heparin, if we would have to do like weight-based heparin calculations at all.
Okay. So very good question. So the in your review packet, you should have what I have pictured here, which is the practice test. And in the practice test, it's a mirror of what you'll see on your exam next week. So the questions that are here, so you won't have the heparin protocol, but you might have some weight-based heparin questions, meaning you have to account for the patient's weight. And a lot of times all that means is you're going to take the patient's weight that's usually given in pounds, divide that weight by 2.2 to get the kilograms, and then just multiply by the factor that is given to you. And there may be one of those on here. Yes, like number 24 would be considered a weight-based question. Let's see if I can get 24 to show up with the Dilan. So we'll come to that. So let's do some of the drip rate and flow rate questions, and then I'll come back to the weight-based question, and then we can cover anything else you guys have. So all right, so let me go back. So the first flow rate question you have in here, and again, I apologize. I'm trying to get this so it stays in focus. It looks a little blurry to me. And yeah, we're going to play with this. So hopefully my draw, or when I write, it'll come out a little bit easier. All right. So for the any flow rate questions, this is actually a drop weight question, because the question says, I know, like I said, it's hard to read. It says the tubing package is labeled as shown. You are ordered to administer D5W IV solution at a rate of 75 milliliters in 25 minutes. What is the flow rate in drops per minute? So really what they're asking is, what is the flow rate? Now, a couple of things. When we're doing flow rates, you need to know two pieces of information. So in order to calculate a flow rate, you need to know the volume and you need to know a time. Now, for typical flow rate, what you're looking for is milliliters per hour. Okay, that's your typical flow rate. But another way that flow rate can be written is just in a different volume over time metric, which is drops per minute. Okay. Now, in order to get from milliliters to drops, we have to do a conversion. And that's what I'm going to show you in this question 16, since that was the first question that was asked. Okay. So let's talk about this first and foremost. Let's just say I want to break this up and just give like almost like create like a separate question out of this. Let's just first calculate what the flow rate would be in milliliters per hour. So my first step, just as a extra bonus helpful quiz type thing, is what would the flow rate be in milliliters per hour? So the first thing is, okay. Is the board still blurry, guys? or can you see my black marker okay?
It's okay.
It's okay. Okay. Yeah, I think you're gonna the practice test, which I'm assuming you guys have, you'll be able to print off and look on your own. I just wanted to be able to write. So I'm trying to raise this up a little bit. I have a light here. I'm trying to see if we can get a little bit better contrast, but okay. So milliliters per hour is what we're looking for. So what I need is volume over time. The question says the flow rate is 75 milliliters, 25 minutes. So 75 milliliters in 25 minutes. Now I don't want minutes, right? I want hours for this scenario. I told if you're, I don't want you guys to get confused. I'm deviating from the question just to kind of show you flow rate and drop rate all with the same question. Now there's two ways to solve this. So 75 milliliters, 25 minutes. If you already know that, well, first of all, don't, because I almost just said the wrong thing. Don't do 25 minutes is a quarter of an hour. 15 minutes is a quarter of an hour. Okay, so I almost told you to multiply it by 4, and that would have been the wrong thing to do. So what you're going to do is you're going to convert minutes to hours. Okay, so there's 60 minutes in an hour. I'm showing you this the slow dimensional analysis way just because flow rates and drip rates are, you can do them doing the desired over half method or quantity over half method. It's just you have to kind of know where to put certain things. And as long as you're doing it consistently, you'll be fine. But for the flow rate and drop rate questions, I will show you dimensional analysis just because for me, it's just easier to display it. So you'll know you're doing this all right because you'll be left with what you're looking for, which is milliliters per hour. So all you do is do 75 times 60 divided by 25. And then the shortcut is just, you can reduce 25 into 75 3 times. And that makes 180 milliliters per hour. Okay. So sometimes you'll have something like 75 milliliters over 90 minutes or 75 milliliters over 20 minutes. If you ever get stuck in how to calculate the flow rate in milliliters per hour, you still want to be able to make that conversion. And like I said, if you ever get stuck, just remember, just convert minutes to hours, and that should help you out. Now for this question, for the flow rate question, when we do, I'm sorry, the drop rate question. So when I'm calculating my drop rate, I need 3 pieces of information. I need the flow rate, and I need the drop factor. And that'll give me my drop rate. So GTT is the abbreviation for drop. So that way, if it's not crystal clear, that's, I'm not writing GH, that's supposed to be GTT. They tell us initially that the flow rate is 75 milliliters in 25 minutes. Drip rate is always going to be in drops per minute. So the secret to this question is don't convert this from milliliters per minute to milliliters per hour. You can do that, but you're adding an extra step that you don't need to do. All you need to do is take that 75 milliliters, 25 minutes, and multiply it by the drop factor. When I look at the label has that big number 15 there. And I know you can't see it on my screen, but it does say 15 drops per ml. So I'm just going to multiply 15 drops per ml. And again, you'll know you've set this up right. Oh, you'll know you've set this up right because you can eliminate the milliliters, and then you're left with your drops per minute. Okay. And then I would just do the same thing I did before. You can multiply 75 times 15 divided by 25. Or if you feel comfortable doing it, 25 goes into 75 3 times. And 3 times 15 is 45 drops. per minute. So that's how you do like question number 16. Are there any questions on any of that I set up?
Yes. So the first answer, the 180 milliliters an hour,
Mm-hmm.
what are you doing with that?
So as I said, that was just like an extra practice, meaning if the question asked calculate the flow rate in milliliters per hour. So that was just extra.
Oh, okay. I get it.
Yeah. So because the original question was some flow rate questions and some drop rate questions, and I just wanted to show you both in the same question. That's all. Good question. Oh, okay. So someone asked, where did the 15 drops per milliliter come from? It comes from the label listed below the question. So that you see that number 15 on your sheet, you'll be able to see it clearer than what I'm able to display. So I'm actually going to, let me see something here. I wonder if this is, I don't think that helped anything. Normally more light is good. So, okay. I have one more thing I want to try. Just give me 1 second. I'm going to put this up on a book. No nightmares, Keisha. I know you remember this book. Okay. Well, that's what we can do. That's fine. Okay. So let's go to another question very similar to this, and I'm going to follow the exact same steps. Okay. All right. So 17, and again, I know you can't read this as well as I can read it, but if you have this copied, it's going into the chat. So if you came in late, just ask somebody to repost what I sent out earlier, and you can get copies of the practice test if you don't already have it. And if I add any additional questions, that's where also the same link where I'll post it. Okay, so 17 says a patient must receive a tube feeding of Ensure 120 milliliters in 90 minutes and to calculate the flow rate in milliliters per hour. Okay, so the question is, what is mill per hour? Okay, now all I'm going to do is I'm going to remember, flow rate is just a matter of calculating volume over time and then just manipulating time. Okay, so volume over time. So in this instance, it's 120 milliliters. And then it says 90 minutes. Now, in the past, I've had students, what they would do is they say, well, okay, if it's 120 milliliters in 90 minutes is 1.5 hours. So they would just multiply the 120 by 1.5 to get their answer. And that works. You will get the correct answer by doing that. If you don't feel comfortable doing that, I'm going to tell you to do the exact same thing that we did in the previous question. Convert minutes to hours. And then I'm going to pull up my calculator. And 120 times 60 is 7,200 divided by 90. And that will give me 80 milliliters per hour. Now, I actually made a mistake when I told you. I think I told you to multiply by 1.5. You'd actually divide by 1.5. So if you are, if you do that, just make sure that you have it set up correctly, because obviously I made the mistake. Now, here's what I would have done. If I had multiplied by 1.5, so 120 times 1.5 would have given me 180 milliliters per hour. Would it make sense that you would be giving more milliliters per hour than you did in 90 minutes? And hopefully the answer to that would be, well, no, that would be, you would actually be giving less than 120 milliliters in an hour because you're going to only give 120 milliliters in 90 minutes. Okay. So if you are doing shortcuts, just make sure your shortcuts work, and realize that even the tutor, me, makes mistakes because I told you to multiply by 1.5 and I should have said divide by 1.5. All right. Another infusion question is number 18. It says the order is 0.9% normal sodium chloride, 500 milliliters IV, infusing at 125 milliliters per hour. And it wants to know how long will this infusion take? Okay. Now, when that question gets asked, sometimes they might be asking how much or how long will it take, in hours and minutes. They want you to be as accurate as possible. So for this question, it's going to actually equal an even hour number. But let's look at the information because this is still a flow rate question. It's just asking the question differently. So what I mean by that is it gives us the flow rate. It says 125 milliliters per hour. We also know we have a 500 milliliter IV. Okay. And then we want to know how long before that 500 milliliters runs out if it's infusing at 125 milliliters per hour. So again, when I'm doing these flow rate type questions, I prefer to use, and like, again, it's my preference. If you have another way and you're getting the same answer, you're not doing it wrong. So you don't have to do the way I do it. But if you don't know what you're doing, this way might be helpful. Okay. So what I'm going to do is I know what my starting volume is. I want to know the time it takes to get that to 0 milliliters, and the rate that it's infusing is going to be there. So I just need to kind of connect these. Now, this is where I think dimensional analysis is helpful, because I know that I want hours, but because I want hours, I need that to be the top number. Okay. And I need to get rid of milliliters. So in order to do that, I'm going to start with my 500 milliliters. I don't want milliliters. I want hours. And then all I'm going to do is transfer the information from the 125 milliliters to the hours. And then I can easily solve this type of equation or this type of problem, because all I'm doing is taking 500 and dividing by 125, and all I'm doing is manipulating the ratio of milliliters per hour. So if you didn't know this already, you can do this. Some of you, I think, are pretty okay with this stuff. And remember, one of the reasons I like dimensional analysis is because you'll know before you do any math that you're in the right, or that you've set up your question appropriately. Some of you get nervous when you don't see what's 500 is over. So it's always over 1 if it's not indicated otherwise. Okay. So 125 goes into 500 4 times. And so your answer for this question would be, it would take 4 hours. Okay. So if it started at 8 a.m., you would want to check it again at noon, 4 hours. Here's another question. Believe it or not, this question right here, number 19, commonly missed. And the reason it's commonly missed, I'm sorry, I know it just keeps fluttering back and forth. It's finding that, it's finding the, what looks like the right thing there. But anyways, okay. This is a commonly missed question. And I think it's commonly missed because it's so easy, you don't know what to do with it. Okay. So it says the patient is to receive 375 milliliters of Ringer's lactate over 3 hours. What would you set the rate on the infusion pump to in milliliters per hour? Okay. So I'm looking to calculate milliliters per hour. And then what do I have? I have 375 milliliters of Ringer's lactate, and then I have 3 hours. So technically, there's no math here. There's nothing to multiply by, but I just need to reduce that number. So if I take my calculator and I do 375 divided by 3, that would give me the number of milliliters per hour. So 375 divided by 3, and you get 125 milliliters per hour. And I do realize, and then sometimes you might prefer to write it out like this. I just want you to know that's the same thing. So just if there's any question, you can ask your lab instructor if there's a question about how they want it written. All right, number 20, we're going to do a similar setup. Now, this is another one that has a label associated with it. So let's just see this. Okay. So it says that the physician ordered 1440 cc's. Now, I hope that you guys know that cc's and milliliters are the same thing, right? Okay. Of D5NS to be infused over 12 hours if your tubing is labeled as below. Do you see that big number 10? That's your label, okay? What will the flow rate be in drops per minute? So remember, in order to do a drop rate question, I need to know the flow rate. I need to know the drop factor. And I need to eventually get it into drops per minute. So my initial flow rate tells me I have 1,440 cc's. Remember, that's the same thing as milliliters. And it's infusing over 12 hours. Do you want 12 hours? No, you need to convert that to minutes. So there's a couple ways you can do this. You can go ahead and reduce this down right from the start, 1440 divided by 12, and then get your cc's per hour or cc's per milliliter. Or kind of like as an aside, you can convert 12 hours to minutes. Okay. So a lot of times, or at least that's the way that I like to show it. I'm going to show you the dimensional analysis way, but you could also just do this as kind of like a workup step. So you don't have to do this the way I'm going to show you next, but you can do it this way if you want to. So if I was going to set this up from a dimensional analysis standpoint, just converting hours to minutes, I would say 60 minutes in 1 hour. Okay. And then I can either go ahead and just set that to equal and find out what that is, or I can just continue with the problem. Okay. Now, a lot of times the reason, I did this all, I did this wrong. I need apparently more coffee. Okay. Sorry about that. And then I can set up another factor if I want to, but I found that working with nursing students over the years that if I start adding more than one factor, you guys start to get upset. So let's just go ahead and find out what this is. So 60 times 12. So all I'm going to do is multiply across the top. So 1440. And then multiply across the bottom, 720. And all I did was I converted hours to minutes. So CC stays the same. Remember that CC and ML means the same thing. All right. Now I'm going to multiply by my drop factor. Now at CCAC Allegheny, your drop factor will always be given to you, and it'll always be in drops per milliliter. If you're at another campus, sometimes they'll refer to microtubing, and microtubing typically tends to be, or at least every time I've seen it as an example, is 60 drops per milliliter. Okay. The number of, according to the label, was 10. So 10 drops per milliliter. And then we're just going to multiply and divide. Now, if you're looking at this and saying, well, 1440 is twice 720, or 720 is, or if you double 720, it's 1440. That's a good way of looking at that. And that saves you a step on your calculator. So you can actually reduce this right away to 2 times 10, and that's where you get 20 drops per minute. Now, the other way, if you were just multiplying across, you would take that 1440 times 10. So don't forget to multiply by 10 equals, and then divided by 720 equals, and you'll get the 20 drops per minute as well in that way. Okay. I don't recommend, even though technically it's correct, to do 1440 divided by 720 times 10, because sometimes you'll get like a 0.99999 answer when you're using those 10 basic 10 key calculators. Just know that if it's 0.99999, that it's a whole number. So if you got 19.9999999, the answer is 20. Okay. All right, the next question that was asked was like a weight-based question. So I'm going to go ahead and look at number 24. All right, so 24 says that you have the order is 15 milligrams per kilogram loading dose, then to give 300 milligrams per day. So it says for the loading dose, how many milligrams of the anticonvulsant Dilantin would you administer to a patient who weighs 176 pounds? So these are what are called weight-based calculations. And you already had some practice with the basic weight-based things of just converting pounds to kilograms. I usually, when I write the tests, I never put going from kilograms to pounds, because this is not something you would be doing. You're going to be making that conversion, pounds to kilograms, because obviously in the United States, that's the system that we use is pounds. But for drug-based calculations, you need to know the kilograms. And so that's why we make that conversion. So for this question, so 24, I have, give me 1 second. I have to first account for the patient's weight in pounds and convert that to kilograms. So I have 176 pounds, and I need to convert that to kilograms. You know how to do this. I'm going to show you the dimensional analysis way. If you just automatically just divide by 2.2, you're doing it right. Okay. So we know that 1 pound is, I'm sorry, one kilogram is equivalent to 2.2 pounds. Okay. We can cross out pounds. And then 176 divided by 2.2 is, I believe that's 80. Yeah, 80 kilograms. All right, now a little bit of an aside. Let's say you got 80.23. You're going to round to the nearest tenth. Typically, in most instances, you do not do your rounding until the end of a question. But for these weight-based type questions, and to also simplify the process moving forward, you're going to go ahead and you're going to round your weight, your patient's weight, to the nearest tenth. So that's why it's important to do that step first, and to do that. Yeah. So someone asked in the comments or in the chat if you're going to be given a calculator, and thank you for answering. Yes, the answer is yes. You will be given a small basic 10 key calculator to use during the exam. So you don't have to, do any long division or anything like that, or long multiplication for that matter. So now that we know the patient's weight in kilograms, it's just a matter of converting kilograms to milligrams. They tell us that the loading dose is 15 milligrams per kilogram. So 80 times 15 will give you 1,200 milligrams. Okay. And that would be the loading dose. Now, what if it asked you how many grams would you administer? Then you would just convert 1,200 milligrams to grams. You can move your decimal over 3, or you can divide by 1,000. But I think you guys can do those conversions if you get to that point. Okay. All right. So those were, at least on your practice test, the weight-based question, the infusion, and the drop rate questions. The other thing, before any other questions get asked, this gets asked quite often, is about the how to do the syringe. Now, this is from
Excuse me.
this is from one, hold on one second.
Okay.
This is from one of the textbooks that I have listed in your practice packet. And basically it talks about when you're drawing up the insulin, you're going to draw the regular first, and notice how they mark the syringe. Okay. So that here's the total. The total in this example is 40 units total. There's 10 units regular, which is that first bracket, and there's 30 units of Humulin N. Okay. So there's 2 different medications, and this is how the a textbook marks the mixing of 2 syringes. Keeping in mind that they're going to mix inside here in reality, so they don't stay separate. But what they want you to be able to demonstrate on a mock syringe is what's drawn up first, what's the total level, and then these are the marks. And this is how I would mark the syringe. And then you have a textbook that would actually show you that that you did that correctly. Okay. So this this picture is also in the Microsoft OneDrive link that I shared with you guys. And so you can see what that looks like. So that way you don't get tripped up on it. So, okay. Someone was asking a question.
Yeah, I wanted to go back on the 24th, but I think we didn't use the other 300 milligram on this question. Can you go back on that for a minute?
Sure. So we don't use the 300 milligrams because it only said to calculate the loading dose. So the 300 milligrams would just be, that's just what you would give them the next day until they were done taking the Dilantin.
Oh, okay.
Does that make sense? So like,
so the loading dose is the same as like per dose, like if I understand.
So like a loading dose is kind of like that initial like push of the medication to kind of get it into the patient's system. And then the rest of it, and then the regular doses is just like kind of like the maintenance dose to keep their levels up. So you actually, next semester, you guys will do like a heparin protocol question. And the heparin protocol basically talks about doing a loading dose. Because if you remember, heparin is to prevent the patient from bleeding, right? So we're concerned that they are a risk of throwing clots. So they're put on heparin, but if you give them too much heparin, they can bleed out. And if you don't give them enough, they could clot. And so you have to do a weight-based calculation with heparin, give them a loading dose, which is usually a higher dose, and then you titrate it down. And Dilantin, at least in this question, is a similar thing. You have a loading dose to get them started, because if they're having convulsions, if they're having seizures, you want to try and get those seizures under control now. And then the medication would be used to kind of help keep it that way.
Okay, thank you.
Yeah, no, you're welcome. And you asked a great question, and I'm glad that you asked it, because I think that's helpful for for everybody.
Can you share more examples, please?
Okay. What would you like to see examples of?
Of something like question number 16.
16. Okay. So give me a second and let me see what I got in my arsenal here. I'm going to cover that up because I know some of you I had for microbiology, and that's those of you that had for microbiology is like also during when COVID all started. So trying to keep that additional nightmare out of your head. Okay, let me see what I got here because I do have some practice questions. Just give me a minute. It's the wrong folder. Actually. Okay, this is actually a good question. So this actually is coming from the 240 practice test. So the fourth semester test. And that's not to say that that makes it harder or easier or anything like that. And you're going to see it looks very similar to a previous question that we had. And so what we're going to look at is question 19, and I'll read it to you so you can see it. And so you'll actually have access to the fourth semester test. So it is available to you so you can get to this question. So this is also helpful because the person that was just asking the question previously was like, you know, why didn't we use that 300 milligrams per day? Well, this is going to be another example of a question where we have extra information that you do not need in order to answer the question. So it says your patient is to receive Solumedrol 200 milligrams IV. It is received from the pharmacy in a 75 milliliter bag of D5W to infuse over 30 minutes. The drop factor is 10 drops per milliliter. No other IVs are running. We want to know what is the flow rate in drops per minute. So let's take that and look at the information. So again, as a reminder, what do I need in order to calculate flow rate? I mean, drop rate. I need the flow rate. I need the drop factor. And we're looking for drops per minute. So in this question, what is my flow rate? Well, my flow rate is the volume over the time, which is 75 milliliters, 25 minutes. You can see how original I get with my questions in that I use the same numbers over and over and over again. So I'm sorry, it's at 30 minutes. So 75 milliliters over 30 minutes. That's what the flow rate is. Okay. Now, do I want to convert minutes to hours in this question? No, I don't, because I want to find out drops per minute. So I don't want to convert minutes to hours because then all I'm going to have to do is go back to minutes. My drop rate is given. It's 10. And I answer the question. Okay. So 75 times 10 is 750 divided by 30. And I get 25 drops per minute. Now, the follow-up question here is, well, what about the Solumedrol 200 milligrams IV? Well, first of all, that's important. But secondly, when I'm calculating a drop rate or a flow rate, that doesn't matter. Okay. It doesn't matter. All that matters is the rate. All right. And so that's one way that you can eliminate extraneous information is when you have something that says, it's 200 milligrams. I use the example that let's say you're going to Kennywood and you're leaving from CCAC, you get a carpool together and one of you is driving a Honda Civic and another one of you is driving a Porsche 911. You're both going 35 miles per hour the whole way there because of traffic. Does it matter, or does it matter what vehicle you have as far as getting to your destination? Some of you can argue, and I would argue with you, that you'd prefer to be in the Porsche, but the other thing is you're both going to get there at the same time. The rate is what we're calculating here. We don't care about the vehicle. And in this scenario, the vehicle is its Solu-Medrol 200 milligrams. It could have been heparin. It could have been the Dilantin. It could have been insulin. Whatever could be put into a flow rate and plugged into an infusion. We only care about the rate when we're calculating rates. Okay. So again, I'm just illustrating that because you have that extra piece of information, which is the 200 milligram IV. All right, let me see if I can find some more because I thought I had some more to show you.
Can you please remind us how many questions will be on the test?
How many?
Yes,
There's 25 questions. You can miss 2.
thank you.
You're welcome. And if there's anything else on the practice test while I'm looking for my other test information, just shout it out. Let me know.
Can you please go over 21?
21, yes.
Okay.
And when you're done, can you please go over 25?
Yes.
Thank you.
And also 15.
Okay, you got it. I'm just looking to see if I have any examples readily available for the flow rate questions. And what I'm going to do is when I get a chance, I'm going to try and post a few more because I do have a whole bunch that I picked up from like your ATI reviews and things like that. And so let's see. All right, let me go ahead and tackle these since we only have 15 minutes left. And then I'll come back and look and see if I have any other flow rate type questions. Okay. So I'm going to go in order. So I'll go 15, then 21, then 25. So 15. Oh, okay. So I already showed you 15. What I showed you was this as the example. Okay. So you have your syringe. The regular gets drawn up first. And then your whatever's not the regular gets drawn up second. And then this is how the dosage calc book reference marks it up. And then I posted this image also in the Microsoft OneDrive folder, so you can see how this is set up. So for like 15, you would do the same thing where you have 10 units of regular insulin and then 40 units of the NPH. You're always going to choose syringe B because syringe B is the only one that has units listed. And also that's the only image I have for this question. So it's always A and B, and your syringe is always B. So when you're marking the syringe, what I'm going to recommend that you do and verify with your lab instructors. Let me just pull this way up here and see if I can do this. So I'm going to draw the syringe very similarly to what you have. Okay. So I'm going to make a mark first at the total, right? So I have a total mark. So I'm just going to put a mark here, and this is at the 50 units. Okay. Between 40 and 50. So this is the 40 unit mark. I'm just going to say 40 units. This area right here is where your regular insulin would be positioned. And then the remainder of the insulin, the NPH, would be in this area here. Now, they only ask you to mark, it says to select syringe A or B, mark the syringe with an arrow, 2 arrows to indicate the solution and amount to be drawn up first. So your first arrow is at the 50 units. And then the second arrow to indicate the correct, or to be drawn up first and the correct total. So the correct total is 50 units. And then what's going to be drawn up first is technically your next arrow, I guess, is going to be here. This is the one where there's a little bit of confusion depending on how the lab instructor explains it to you. But when you go to the lab, or when you go to the book, and you can see here that they mark, I'm going to raise this up so you can kind of see it a little bit better. You can see the 10 units. Well, I guess that's not going to help out any. The 10 units is right in this area right here. That initial regular insulin is right here. So you could have a mark here and a mark here. And honestly, with the marks, they just want to make sure that you know, like when you get like a number that doesn't end in 0, that it's like on a 2, a 4, a 6, or an 8 on those little individual lines. And that's kind of what they're testing you on with this. That's why, there's not math here. But if you look at these little individual lines, they're increments of 2. So you have 10 between each. So like, let's say your total was at 42 or 44. They just want to make sure you're marking that correctly and that you know to draw up the regular insulin first. In the past, what I have also recommended, when it says solution and amount to be drawn up first, I write that next to this question here. So there's no question that you know which one to draw up first. So you'd say 10 units regular insulin first, and then your correct total medication then would be the total of the NPH plus the regular. But if you mark the syringe like they did here, then you are even more correct, at least from the standpoint of having a reference that you can fall back on in case there's an issue with this test. With that, I think usually the main reason that people miss this question, number 15, is because they don't mark the syringe. Okay, so that was 15. Then 21. So 21 is considered a suspension type question. So the order requires 60 milligrams of a drug to be administered intramuscularly. The vial has the following 3 choices of strength after reconstitution: 5 milligrams per milliliter, 10 milligrams per milliliter, 20 milligrams per milliliter. And it says determine the volume in milliliters for the strongest concentration. So all of these concentrations are going to be basically like your different vehicles. Okay. You got the, the Chevy Malibu, you got the Honda Civic, and then you got the Porsche 911. And it says pick the strongest concentration. Well, the strongest concentration is always going to be one that is the highest number, right? The only time that would change is if each of the volumes were different, but in this instance, none of the volumes are different. So you're going to take the 20 milligrams per milliliter because that is the highest dilution or the highest factor. We need 60 milligrams, or we need to calculate 60 milligrams. So we need to know how many milliliters to administer, and you get the 20 milligrams per milliliter. Now, if you want to do desired over have for this type of question, that works out great for this question. All you got to do is do 60 over 20 times your quantity, which is milliliters, and then you're going to give them a 3 milliliter intramuscular injection of whatever this medication happens to be. It doesn't qualify what it is. Okay, so that's how you would do 21. And 22 is the exact same thing. It's just you ignore this column completely and just take the strongest concentration. So it's a 1 million units per milliliter. You take the 750,000 units divided by the 1 million units, and then you get your volume. All right. And then 25. So 25 says that the physician prescribes 500 micrograms of entecavir per day via NG for a patient with chronic hepatitis B virus infection. The oral solution contains 0.05 milligrams of entecavir per milliliter. And the question is, how many milliliters would you administer? Okay, so let's look at some of the pieces of information that we need to solve this question. We need 500 micrograms per day. And then we need to inject this. So that's why we have a conversion. So let's just write the information. So my order is the 500 micrograms. Okay. Then what I have available is the 0.05 milligrams per milliliter. Now, the first thing you should be looking at and noticing is that we have micrograms and milligrams. Okay. We can't just have, we can't work with that. We need to make a conversion. We need to convert either micrograms to milligrams or milligrams to micrograms. Either way, we have to make a conversion. So just so we don't have to deal with the milligrams and milliliters, let's just go ahead and we're going to make the conversion of micrograms to milligrams. And so in order to do that, I'm just going to make a factor here. I know that my conversion between micrograms and milligrams is that 1 milligram contains 1,000 micrograms. Okay. And then when I do this, I get 0.5 milligrams. So 1, 2, 3. Yeah. Okay. 0.5 milligrams. Now I can do something with this. Now I can take my order after I've converted it to 0.5 milligrams, and I can find out how many milliliters given my concentration or my what I have available to administer. So it's 0.05 milligrams and then 1 milliliter. 0.5 divided by 0.05, and you get 10 milliliters. If you had wanted to convert milligrams to micrograms, you could have done that. And all you have to do is worry about this number. It wouldn't change the milliliters. Okay. So you could do milligrams to micrograms, just multiply by 1,000, and you would have gotten the same thing. You would have gotten 50 micrograms, and then you would have come up with the same answer of 10 milliliters for the injection. Okay.
Dr. Rad,
Yes.
could you please quickly go over question number 3 and 4?
Sure.
Yeah, my question for number 3 is that I believe I can round the number because it's a conversion from metric to American measurement, right?
Correct. Right. Yeah. So you're not, well, you don't round between this when you're going from the same unit to the same unit. So like if I'm going from milligrams to grams, micrograms to milligrams, do not round.
Right.
When you go from different units between units, you can round. That's not a problem. So like number 3, so I'm just going to push this up here. And number 3 is, it says 135 milliliters. And then we want to know how many ounces that is. Okay. So in order to do that, we know that 1 ounce is 30 milliliters, correct? 1 ounce is 30 milliliters. So when I do 135 divided by 30, I get 4.5 ounces. That is your answer. Okay. You don't need to round that up to 5. That's your answer. Round to the nearest 10th.
And how about number 4 for lowercase t means teaspoon?
Teaspoons. Yep. Yep. So for number 4, and the nice thing about when you go from, a lot of times when you go from the US standard system, like teaspoons, tablespoons, even ounces to milliliters, a lot of times you won't have to worry about rounding at all. So 2 teaspoons, okay, is the same thing as 1 teaspoon is equal to 5 milliliters. So 5 times 2 is 10 milliliters.
Thank you.
And I'm going to challenge you guys, because if you're ever at home and you're cooking or baking or making something that requires measuring out teaspoons and tablespoons, look at those teaspoons and tablespoons carefully and closely, and you'll see that the equivalent in milliliters is listed on there as well. The only reason I say that is because it'll help you to anchor what that is. I mean, every time I make something that requires a teaspoon or a tablespoon, I always double confirm the fact that it's also listed on there as teaspoons and tablespoons. And then honestly, with our global world, you're going to find that amazing recipe on Pinterest, and it's going to be from the UK, and everything's going to be in metrics. And so thankfully, all of our measuring utensils also have metric units. If you need to get 500 milliliters of this and 10 milliliters of that, you can still calculate that out. So I will be back for you guys's or your the 1:30 class in the afternoon. I think the time is, oh, I put that down somewhere. And then, and I'll also be back at this time on Thursday. So if you have any other questions, please feel free to email them over to me. And then Tova, since you asked, I am trying to work on getting some more drop rate questions, and I know I have some saved somewhere, and I'll get those. Oh, the next 1:30 time is at 3:45. So you're welcome to stay on, but I'm going to be welcoming the 2:20, 2:30 group in at 1:15. So okay, I'll talk to you guys later.
Today you're having a, I'm sorry, sir. Today you're having a 1:30 drop calculation class at 3:45 today.
Yep, I'll put it right there. That way
Is
you
it
guys can
today
see.
or on the 14th? I don't know.
Yep.
Excuse me.
You have it today and the 14th?
Correct. Yep. So today is the 12th, and I'm doing all these times, and then the 14th, all these times. So I'm repeating everything twice.
You will have a new question on 3:45, or it's the same?
It'll be the same practice test. So like I said, I thought I had some more of those types of questions available to me, like right beside me, and I don't have them with me. So
Okay.
So the
Right.
practice test too, do you have them on Blackboard that we can print it out and try them?
in the if someone's still on here and is connected, just copy paste what I posted on there already. You can just download them. It's also in the packet. Thank you. It's also in the packet you received at the end of last semester.
Dr. Rat,
Yes.
I'm sorry. I just want to clarify something about the timing. On the today, you say you have another section for 3:45.
Yep. Everything. Do you see it displayed on the screen there?
Yeah, but it's 1:30. Oh, okay, okay. It's the same timing for both days.
Correct.
Okay, okay.
Yeah. So today and Thursday at noon and at 3:45 for your section. And then you notice that the Zoom link is exactly the same. So you're always welcome to jump in on another time. But I will prioritize the 2:20, 2:30 people, but they don't have questions. You can ask your questions. I don't have a problem with that.
Okay, thank you.
Can you remind, please, if you have time, or I will do it later, number 6?